The second study design in analytical epidemiology study is cohort studies. In cohort studies, a group of subjects selected to represent the population of interest is studied over time. Information is collected about the outcome of interest and exposure to risk factors. In cohort studies, subjects are disease-free at the outset of the study, and at distinct point of time, data are collected relating to health outcomes and exposure to risk factors. Cohort studies are used to examine causal factors. There are two types of cohort studies. The first one is prospective cohort, and second one is retrospective cohort. In prospective cohort studies, studies are carried out from present time into future. Prospective cohort studies can be tailored to collect specific exposure data, but the researcher need to wait long for events to occur. Prospective cohort studies are expensive and prone to high dropout rates. Retrospective or historical cohort studies look at medical events from some time point in the past up to the present time. The advantage of retrospective cohort studies are information are available immediately, and the disadvantages is the first one is it's difficult in tracing subject, and second disadvantage is reliance on the memory of subjects and or the quality of recorded information. This figure here shows the difference between prospective and retrospective cohort. In prospective cohort, the researcher moves from the present time to future, whereas in retrospective cohort, the researcher collects the data from present time and moves backwards to the past. This figure here shows how the cohort study design is being carried out. So the study begins here, and at the start of the study population is free of disease. And throughout the time, the factor is measured whether it's present or absent. And among those who with present factors, in future the researcher will see whether the individuals develop disease or no disease. Similarly, among those with factor absent, the researcher will identify those with disease and those without disease. When discussing the time frame of studies, in prospective study, we look forward, look to the future, or examine future events, follows a condition, concern, or disease into the future. At the baseline of prospective cohort study, we measure the exposure and also the confounder variables, and we identify those who are exposed and non-exposed. At the end of the cohort, again we identify those with outcome and those without the outcome. The time frame for retrospective study is to looks back in time to study events that have already occurred. And in a retrospective cohort study, when the study begins, we already have the outcome, and we look back towards the exposure, whether they are exposed or not exposed, and finally, we measure the confounder variables. One of the important aspects of cohort studies are selection and follow-up of subjects. In prospective cohort study, there is an issue of healthy entrant effect, where a disease-free status on entry to the study. Initially, subjects are seen to have lower levels of disease than might be true of the population in general. This will happen with an acceleration of disease rate over time. Following cohorts from birth may overcome healthy entrant effects and may result in lengthy and costly study. Follow-up of subjects is carried out to monitor changes in health status over time. loss to follow-up will increase with the length of study. So the researcher need to plan mechanism to achieve lowest possible dropout rate. Besides, there is also systematic differences between those who drop out and those who stay in study, and this is related to the outcome of or exposure to risk factors. Analysis of data must therefore include a comparison of risk factors between individuals who remain in study and those who have dropped out. If loss to follow-up is ignored, the reliability of study conclusion can be questioned. Another issue in prospective cohort studies are inferring causality. To infer causality with any degree of certainty, we need experimental study design. A longitudinal nature of cohort studies enables the assessment of causal hypotheses, and is known if exposure occurred prior to outcome. Measuring changes in level of exposure over time alongside changes in outcome measure gives information on dose response relationship between exposure and outcome. Higher level of exposure associated with higher level of outcome provide further argument for causality. Now, let's look at hypotheses of cohort studies. When a straightforward comparison of two groups, those with exposure and those without exposure, the null hypothesis is, on average, the disease in the exposed group is no different to that of the unexposed group. As an example, comparing cancer occurrence among those who smoke with those who do not smoke. When there are more than two groups in a cohort study, example, the smoking status are split into those who do not smoke, those who smoke fewer than 20 cigarettes a day, and those who smoke over 20 cigarettes a day. This type of grouping in strata, it has three hypotheses. The first null hypothesis is, on average, the outcome rates in groups of subjects are no different to that of the outcome as a whole. The second null hypothesis is, on average, the outcome rates in groups of subjects are no different from each other. And the final null hypothesis is, on average, there is a linear trend in outcome rates across groups. Let's now move to analysis of data in cohort studies. Statistics from cohort studies are divided into three categories. The first one is crude rates of outcome. The second category is standardized rates and ratios of outcome. And the final category is risk ratio of outcome. In crude rates, number of individuals with the outcome out of the total cohort study size is being calculated. So you can see that A plus B over N. Standardized rates and ratios can be calculated using demographic information so that rates of the outcome are adjusted for other potential risk factors such as age and sex. This is normally being done using statistical software. And the third outcome is risk ratio. The risk of the outcome is exposed to subjects relative to those not exposed to subjects. So this risk ratio or RR have been covered in our previous lecture. Moving on to the advantages of cohort studies. The temporal dimension, whereby exposure is seen to occur before outcomes, gives some indication of causality. Cohort studies can be used to study more than one outcome and good for the study of rare exposure. Cohort studies can measure the change in exposure and outcome over time. In cohort studies, incidence of outcome can also be measured. There are several disadvantages of cohort studies. The first one is it is costly, but it's less for retrospective. Cohort studies also may take long time, particularly when the onset of the outcome measure can occur both early and later on the life. Cohort studies require accurate records for retrospective studies. And when studying rare outcomes, a very large sample size is required. Cohort studies are prone to dropout, and changes in etiology of disease over time may be hard to differentiate from changes observed as age increases. Cohort studies also prone to selection bias, where a difference in incidence of the outcome of interest between those who participated and those who did not participate in the study will give biased result.